Hi, everybody. Section 6.3 is what this video is about, conditions for parallelograms. Lots of conditions. There's like 5 of them. And so kind of need to make sure that we're keeping meaningful notes and keeping track of things. And we'll talk about it in class. Um, Remember the notation we talked about in the last video? That can be really helpful with your notes. And one isn't too short. It's a pretty big one, but it's shorter than what the original is. So let's go through these. If one pair of opposite sides of a quad are parallel and congruent, and notice it's marked, then the quad is a parallelogram. So it would have to be a parallelogram. Remember, parallelogram means there's 2 pairs of parallel sides. That's the definition. I'm going to prove this one right here. If both pairs of opposite sides are congruent, of the quad are congruent, then the quad has to be a parallelogram. So let's just talk through what a proof would look like for this. So I would draw a diagonal. Okay. And so I formed 2 triangles. This diagonal AC is congruent to itself by the reflexive property. So if you look, I've now formed 2 congruent triangles. Okay. All the parts of those triangles have to be congruent. What that means is each of the angles in the triangle up here has to be congruent to an angle down here. And so if you look at this angle right here, I can put an arc mark here. Which angle in the lower triangle would that be congruent to? Well, it has to be congruent to this one, because this arc mark is between the 2 tick mark and the 3 tick mark side. So is this one. Okay. This angle down here is between the 1 tick mark and the 3 tick mark side. So I'll double tick mark it. And we'll do it that way. Okay. Now look at what I have. This angle and this angle are called alternate interior angles. Since they are congruent, that means that this line has to be parallel to this one. Same thing here, double arc marked. So that means this one is hard to see with the pen I'm using here. This line has to be parallel to that one. And so by the definition, since both pairs of opposite sides are parallel, it has to be a parallelogram. So these are kind of like, if you remember the SSS, SAS, that type of thing, these are kind of shortcuts to show that things are parallelograms. Here's the third one. If both pairs of opposite angles of a quad are congruent, then the quad is a parallelogram. I'm just going to mention those. I might even talk about one at the bottom here. It says 634, if an angle of a quad is supplementary to both of its consecutive angles. Remember, we had consecutive angles. So you're looking at this angle right here. It is supplementary to this one. And that's what this notation means. Just note that if you add these 2 together, 180 minus x plus x is 180. That's why those 2 are supplementary. Same thing here. So it says if an angle is supplementary to both of its consecutive angles, then the quad is a parallelogram. And the last one, if the diagonals of a quad bisect each other, then the quad is a parallelogram. So bisect means they cut them in half. And notice how there's double tick marks here and single tick marks here. I was thinking about proving this one. And if you want to see that, I'd be happy to prove this or any of the other ones in class. The most important thing in this video is that you know what I just went through is summarized in this box right here. Here's what I would do the way that I am as a learner. And I know some of you are too, but this is just a suggestion. Read through this at least 3 times a day and maybe even a few times at night, okay, to help make them stick in your head. And it's the abbreviated version. So if you want to just take meaningful notes, if you just somehow take a picture of this, put it in your notes or copy it down, I think it's key to success in this section and one of the keys to success in this chapter. Thanks for listening.